The topic today we are going to see is quick sort. We are going to analyze the quick sort. Sorting is the process of arranging the elements in ascending or in descending order. Today we are going to see how to sort the elements in an array using quick sort. Unlike merge sort, which follows a divide and conquer strategy by dividing the elements based on the position. This quick sort divides the array based on the values of the elements. Let us see it through an example. Now, let us see an array A, which has 8 elements ordered from 0 to n minus 1. So, the leftmost element is L and the rightmost element is R. There are many ways for choosing a pivot because quick sort partitions an array based on the pivot element. Now, for simplicity, we are going to choose the first element as the pivot. Choose the leftmost element as the pivot. Then, take the same value as I and the rth element as j, which is the n minus 1 element. If a of I is less than or equal to pivot, increment I. If a of j is greater than or equal to pivot element, decrement j. Now, I is equal to pivot, so increment I. J is greater than pivot, so decrement j. Now, check whether a of I is less than pivot. Yes, my a of I is less than pivot, so increment I. Then a of j, here the a of j becomes less than pivot, so the j scan stops here. Now check I. A of I is less than pivot, so increment I. Now check, a of I has become greater than pivot and a of j has become less than pivot. So stop here and swap a of I and a of j and check whether I is greater than j. Now my I value is 3 and j value is 6. Therefore, resume the scan. So check a of I is less than pivot, increment I. A of j is greater than pivot, so decrement j. Now, a of I has become greater than 5, which is the pivot, and 2 has become less than pivot, so both I and j scan stops here. Then, what you have to do is swap a of I and a of j. Swap a of I and j. So, we have swapped a of I and j. Now check whether I is greater than j. Yes, I is not greater than j, so resume scan. So, you have to check whether a of I is less than pivot. Yes, a of I is less than pivot, so increment I. A of j is greater than pivot, so decrement j. Now, a of j has become less than pivot and a of I has become greater than pivot. So, you have to swap a of I and a of j. Then, you have to check whether I is greater than j. Yes, my I position is 5 and the j position is 4. So, you have to swap both I and j. Okay, the point here is, here we should not swap when I has become greater than j. We should not swap a of I and a of j. What must have been done here? We must have swapped a of j and a of pivot. So, undo the earlier swap. So, we have got 8 and 2 again. Now, we have to swap, 2 and 8 again. Now, we have to swap a of j with pivot. So now the pivot has come to its correct position. So the array has been divided into two halves, lesser than pivot and greater than pivot. Now this half will be taken as array 1 and this half will be taken as array 2. And quick sort will be recursively applied for the left half of the array and again for the right half of the array using the same procedure until we get a sorted array. So with this, we are going to see the algorithm for quick sort. From that example, we derived this algorithm. This array contains, which takes the input as a of 0 to n minus 1. And it is going to produce the output, that is a half array with a split position j. Now, the pivot element has been taken as a of l, and the lth element's index is taken for i's value, and rth element index will be taken for jth value. And I will be incremented until a of I is becoming greater than or equal to pivot, and j will be decremented until a of j is less than or equal to pi. If the conditions fail, we have to swap a of I and a of j. This swapping is valid until only I is greater than j. Or else we have to undo the earlier swap. That means a of I has crossed j, so we have to swap the a of pivot and a of j. The a of pivot is the first element, that is the lth element. Then you have to swap a of I and a of j when I has crossed j. Now the pivot element has come to its position and the array is divided into two halves. One is less than pivot and the other one is greater than pivot. And finally, the output will be the split position j. Next, we are going to analyze this algorithm, which is the best case. The best case is nothing but every time the array will be divided exactly at the middle. The best case is nothing but every time the array will be divided exactly at the middle. With this, we are going to analyze this algorithm. For divide and conquer algorithm, we use the master's theorem for the analysis. The master's theorem states, if a is less than b power d, the output, the efficiency class will be theta of n power d. If a is equal to b power d, the efficiency class will be theta of n power d log n. If a is greater than b, the efficiency class will be theta of n power log a to the power b. And now let us see the recurrence relation. The recurrence relation for divide and conquer equation is T of n is equal to a into T of n by b plus f of n, where f of n is a function of n power d. And in the best case, we have assumed that the array will be exactly divided into two halves. Therefore, for simplicity, we always take n is equal to 2 power k. If so, the array will be exactly divided into two halves. Out of these two instances, we have to solve all the two instances. And finally, we have to take all the n elements to produce the output. And see, best of one element is 0. Now we are going to find the recurrence class for this recurrence equation. Here, a equal to 2, that is, we have to solve all the two instances. And the problem is divided into two halves, and d equal to 1, because in order to get n here in this recurrence equation, it must have been in the format n power 1, that is f of n is an element of n power d. Therefore, d equal to 1. So a is 2, b is 2, and power d is 1, which gets you to the class a equal to b. So which is theta of n power d log n as the efficiency class of quicksort algorithm. The quicksort algorithm. Therefore, C best of n of quicksort is theta of n power d log n, and substitute 1 for d, which gives C best of quicksort is theta of n log n. Thank you.